Gravimetric analysis is a laboratory technique used to determine the amount of a substance present in a sample by measuring the mass of the substance. In this experiment, we will use gravimetric analysis to determine the amount of lead present in water sample. Lead is a toxic metal that can be present in water due to various sources such as industrial activities, old pipes, contaminated soil. The presence of lead in water can cause significant health problems, especially for children and pregnant women. Thank you.
This part is the theory of gravimetric analysis. First, let's talk about the principle of gravimetric analysis. Gravimetric analysis is an analytical chemistry method used to determine the amount of an analyte by measuring its mass. The analyte is converted into a pure, stable and insoluble compound that is isolated and weighed. For example, lead ions are precipitated using sulfuric acid to form lead sulfate, which is then dried and weighed. This method is known for its precision, accuracy, and cost-effectiveness, but it requires careful handling to ensure reliable results. For lead determination, lead ions are precipitated as a lead-containing compound. Chemical reaction involves, which is lead ions Pb2+ are precipitated using a suitable reagent, such as sulfuric acid, which is H2SO4, to form lead sulfate, which is PbSO4. Next is the advantages of gravimetric analysis. First, high accuracy and precision. Gravimetric analysis is based on mass measurements, which can be made very precisely with modern analytical balance. The second is simple and cost-effective. It does not require expensive or sophisticated instrumentation. It is accessible and cost-effective for many laboratories. And lastly, is a direct measurement. The analysis involves direct measurement of mass, reducing the potential for errors associated with indirect measurement or complex calibration procedures.
Hi, my name is Farah Wahida binti Arifin. I will continue about the methodology for gravimetric analysis. There are 6 steps, which is preliminary treatment, precipitation, filtering and washing off, drying, weighing and calculation. The first step is weighing the sample to be analyzed and then dissolve the sample in water. Then add a suitable chemical to form a precipitate. Next, we need to filtering the sample using filter paper to collect the precipitate before let the sample drying. Lastly, weighing the sample until the constant mass of precipitate is obtained.
As a result, gravimetric analysis might sound like a mouthful, but it's a straightforward process with a huge impact. Here's the example of industry that utilize gravimetric analysis. Gravimetric analysis aids in assessing water quality in river, lake, and ocean. Scientists use this method to identify pollutants or contaminants affecting aquatic ecosystem, enable effective conservation and management strategies. In food and beverages production, water is used in a large scale for cleaning, cooking, and ingredient preparation. Gravimetric analysis ensure that water quality meets required standard for consumption and production. It also helping to detect contaminants or impurities that might affect the final product taste and safety. Why is gravimetric analysis is important? Well, it's to identifying harmful substance, allows for target cleanup efforts and better conservation strategies. It may also help to keep aquatic ecosystem thriving and ensure safe, clean for daily basic usage too. Scientists will collect a water sample from river, lake or ocean, and then they will add chemicals that react with pollutants, causing them to form a solid participate. From the participate, we can determine the concentration of contaminants in water.
In conclusion, gravimetric analysis is a quantitative method for accurately determining the amount of substance. Gravimetric determination of lead is a common analytical technique used to determine the amount of lead present in a sample. There are a few benefits from gravimetric analysis, which is high accuracy and precision, simple and cost-effective, and direct measurements. Moving on to the implications for environmental health. Areas where high lead concentrations require immediate remediation efforts. Continuous monitoring is necessary to track changes and enforce regulations to ensure safety and compliance. Finally, for future recommendations, implementing more advanced analytical techniques with lower detection limits will enhance the accuracy of measurements. Additionally, expanding the study to include other heavy metals and pollutants would provide a more comprehensive understanding of environmental contamination and help develop more effective remediation strategies.